The next topic we have here is projectile. Projectile. And what is projectile? A projectile is any object thrown into space and influenced only by gravity, ignoring air resistance. I will explain. So in the absence of air resistance, that's when projection occurs. That's when you see projectile or a projectile motion. So a projectile motion is the motion of a projectile. Okay, so let's understand what a projectile is, so that you can easily know what projectile motion is. So a projectile is an object, okay, thrown into space. When you say an object is thrown into space, you throw the object into maybe the atmosphere or the air, into any space. You throw the object into space, and the object is influenced by gravity, gradually influenced by gravity. For example, if I throw a table tennis from here, I throw this table tennis upwards. The table tennis don't just fall straight like this. No. If I throw the object like this into space, the table tennis will not just descend like this. No. The acceleration continues to reduce as it descends. It continues to reduce as it descends. It continues to reduce as it descends. That object that I threw into space to get that curved motion on air, this kind of curved motion, because of the influence of gravity, the slow influence of gravity, okay, the gravitational pull on the object, as I threw the object into space, is going to decelerate gradually until it hits the ground. That deceleration of the object is going to bring about a reduction in angle. The angle of the object will be reducing. So that path that object follows is called a projectile motion, and the object is called what? A projectile. Take for example what we have on the screen. You can see the angle of the resting point of this ball. This is a person attempting to kick this ball. So when this person kicks this ball, so this ball has been thrown into space and as an object. So the person kicks the ball and the ball begins to accelerate. Here is the maximum acceleration of this ball before gravity. It can start to feel the heat of gravity. When the ball fell, they go for here. The ball was able to beat acceleration due to gravity because the force that was applied to the ball created a velocity that is greater than the acceleration due to gravity, which is 9.8. So that's why the force was still enough. So as the ball continued to accelerate, the force continues to decrease because it's not a constant force. It was just an applied force. Okay, it's not a constantly applied force. So as the force decreases, this was when the force started to decrease as it got to its maximum acceleration or the maximum height of this ball. Okay, this is the maximum height. So the force don't finish for here. The acceleration due to gravity, which is 9.8, is now greater than the acceleration of the ball. So that's why the acceleration of gravity now started acting on the ball here, started pulling the ball down as its velocity decreased until it finally hits the earth. So this part created by this ball, this line created by this ball on the space from the point of rest into space, then to the point the ball hits the ground back to rest, this is what projectile motion. This motion, this C motion, this curve motion is the projectile motion. Then the object fired into space, this ball, is the projectile itself. You can see the changes in angle as the ball travels in space. Okay, this change in angle is the projectile motion, or the path created by the projectile. Ignoring what? Air resistance. Ignoring air resistance, you are going to get this projectile motion beautifully. Equation: launch speed equal to u. So launched speed, the speed where they launch the projectile, is equal to u. Remember, u is equal to initial velocity. So you should know that a launch speed, that's the speed that they used to launch the projectile. Okay, that speed is the starting speed. Okay, because it was at rest prior. So that's the starting speed, that's initial velocity. So it's still the same thing. Launch speed is equal to u, while the angle is equal to theta, while the what? G is equal to gravity. All these are the basic contents of the projectile formulas. I think projectile has up to 3 formulas, and JAMB loves repeating questions from this formula. It's very easy. All you have to do is substitute everything into your equation and get your answer. Or what's important is you're knowing what each of the letters or each of the symbols in the equation represents. That's it. And know the equation for each calculation. Okay, know the equation for each calculation. For example, the formula for time of flight of a projectile, which is capital letter T. Time of flight is capital letter T, big T. Okay, time of flight is capital letter T. There's T, another one which is small t. Okay, that one is time taken to reach the maximum height, small letter t. But JAMB didn't ask us to know that one. Okay, it's not part of the syllabus. So time taken to reach the maximum height is small letter t, while the time of flight is the capital letter T. So time of flight of a projectile, the formula is capital letter T equal to 2u sin theta over g chikina. 2u sin theta over g chikina. You don't get your answer. Very easy. So if you are calculating the time of flight, all you have to do is to substitute your parameters into the equation. Okay, so you substitute initial velocity, sine the angle. They always give you an angle. They can give you angle 70, angle 90, angle 50, angle depending on the angle. Okay, so you are going to put it sine. Maybe they give you angle 70. You put sine 70 over acceleration due to gravity, which is 9.8 usually. Or if you were given 10, you use 10. That's it for the time of flight. Then the maximum height, the same thing. Maximum height is h, capital letter h. Capital letter h is equal to u square sine square theta over 2g. So maximum height of a projectile is u square sine square theta over g. That's the formula. So if you want to solve, you substitute. So all these formula, you have to know them. No manipulation for you. You have to put them in your head. It's very easy. So the range of a projectile is r. R stands for range. Capital letter R is equal to u square sine 2 theta over g. So because you have 2 theta here, basic mathematics, you are going to times 2 times theta sine what you get. So you are going to times the theta by 2. Maybe the theta is 20, for example, the angle is 20. You are going to times 20 times 2, we give you 40. So you will now do sine 20. Okay, u squared sine 20 over gravity. So from a height, add vertical displacement 10. If the object is falling from a height, you are now going to use acceleration due to gravity formula, which is this one, because it's falling from a height. Because this one is not an object was fired into space kind of question. No, this one is an object falls from a height. So you are going to use acceleration due to gravity, depending on what you are asked to solve for. Okay. I'm also going to treat the high heat calculation, so do not worry yourself so much about calculations. But all these calculations you find here are easy. I don't think I'm going to teach all these ones because it's easy. You have to put the formula in your head. Okay. Put the formula in your head. You substitute and get your answer. It's straightforward answer. It's those complex calculations that are high heat that I'm going to teach. All these ones are easy. Substitute, basic mathematics, solve and get your answer. Very easy, Chikina. What are the applications of projectiles? JAMB wants you to know this, okay? The first is ballistics. You hear intercontinental ballistic missile projectile. You launch it, it gives that projectile motion. So it's also used in what? Rockets, okay? To fire rockets. You know, say rockets, they go like this, see? Rocket don't they go straight, they go like this, fire to space, okay? Then missiles, like I said, intercontinental ballistic missile, okay? Then sports is used in sports, sport like football. The first example I gave you here as regards projectile and projectile motion was football. So if you play ball no, they go straight like this. Most of the time you have to do the ball like this. Throw the ball in a, give it a projectile motion for you to achieve your required results, okay? Which is scoring goals or playing through pass. Also basketball, projectile motion is very, very much required in basketball because you have to throw in a projectile motion. You have to throw the projectile, which is the ball, in a projectile motion so that it can easily drop into the net. If you throw it straight, it's not going to drop into the net, okay? So we also use it for sports like javelin throwing, okay? We use it in javelin throwing. It's also used in pole vault sport. It's also applied in water fountains where water will be doing like this. See, that C motion is still there. So anything that has that C motion in space, you use projectile. You apply projectile in it. Okay, the mechanism behind it is, or the physics behind it is projectile and projectile motion. This brings us to the next topic: motion in a cycle. The motion in a cycle, they include various motions that we are going to explain here. The first motion in a cycle we have here is angular velocity. And this W here that looks like Nyash is angular velocity. This is the symbol. This fine W is smooth like Nyash is angular velocity. And what is angular velocity? Angular velocity is a velocity at an angle. At an angle. Okay? A velocity at an angle. It follows an angle. Okay? Angular velocity at an angle. Change of rate of displacement at an angle. What is the definition they gave here? Rate of change of angle. So when a velocity changes angle. For example, if you look at the projectile motion that we explained, this is the projectile motion we explained. This velocity here, created by this projectile, which is the ball, this is an angular velocity because there was a change of angles, okay? There was a change of angle. The angle from here to here is not the angle from here to here. You can see. The angle from here to here is not the same angle with the one you have at this maximum height. So there was a change of angle, okay? There was a change of angle in one place or the other. Even when it was dropping, when it was descending or decelerating, there was a change of angle until it finally hits the ground. So all the changes of angle here is known as what? Angular velocity. And the unit of angular velocity is rad per second. This rad here stands for radius. So radius per second. And the formula for angular velocity is W like Nyash is equal to theta, which is the angle, over T equal to this one. So you can either use this one or you use this one, depending on what parameters you were given in the question. If you were given velocity and radius, and you are told to look for angular velocity, you use this formula, V over R, to get your answer. If you were given angle, which is d theta, over time, and you were told to look for angular velocity, use this formula. You can as well define angular velocity simply by saying angular velocity is the change of rate of angular displacement. Angular velocity is the change of rate of angular displacement. I'm not here to make you cram definition. That's why most of my students, when I teach, most students understand me when I teach. I'm here to make you understand the concept. Like I said before, the change of the angle of a subject under displacement is angular velocity. When a subject is in velocity and it changes angle, okay, that angle that the object changes due to velocity changes, okay, as the velocity of the object changes, it changes angle, high and low angle. If the velocity is reducing, it starts having a lower angle, okay. If the velocity is increasing, it gets a higher angle. So that is known as angular velocity. Hope you know what radius is used for. Radius is used for area, okay. So area is measured with radius. That's why you have radius second here. So the area covered per time, area per time. So the next we have here is angular acceleration. What is angular acceleration? Is the rate of change of angular velocity. Remember the way I defined angular velocity for you, I said the rate of change of angular displacement. Angular acceleration is the rate of change of angular velocity. Chicken as easy as that. And what is the formula? Since it's the change of rate of angular velocity, the formula will be change of angular velocity over change in time. So change of angular velocity over change in time. So when you say change of angular velocity, it means that the difference between the two velocities. When you say the change of time, it means the difference between the two times. So you minus the final from the initial, or the second from the first, and you divide both sides and get your angular acceleration. Very, very, very easy. Basic mathematics, you are getting all your answer. All that is needed is knowing the formula. All these formulas are easy. We haven't even gotten to complex formulas yet, but we will all get there. The next we have here is centripetal force. And what is centripetal force? It's very easy. Centripetal force is the force that keeps a body round a circular path. The force that keeps a body round a what? A circular path. That is centripetal force, okay? And the formula is, it has two formulas, okay? Depending, the formula that you are going to use to solve for centripetal force depends on what you are given, as parameters in equations, okay? So what you are given is going to determine. That's why you need to know the two formulas. All these are small formulas now. The first formula here is F, which is the centripetal force, is equal to mb over r, where m is equal to mass, v is equal to what? The velocity squared, okay? Over r, r is equal to what? Radius, which is also the area, okay? Measured in radius, that's the r here. So it depends on what you were given. If you were given mass, you were also given velocity, and you were given area, you use this one to solve it to get the answer. But look at this other formula we have here. If you were given angular velocity as part of your parameters, and you were given mass, you were given radius, is this formula that we use when you have angular velocity inside. Because if you go and use this one, where are you going to put your angular velocity? Nowhere to put angular velocity now. So you are going to use this one. So these two formula of centripetal force, so it depends on the parameters and the question that was given to you. That's what is going to determine the one that you are going to use, okay, to get your centripetal force. That's that for that. Then the next we have here is centrifugal force. And what is centrifugal force? It is the force that pulls a body from the center of a part or a circular part. The force that pulls a body, that drags a body from the center of a cycle. Remember, centripetal. Remember, centripetal is the force that keeps a body rotating around the circular part. But centrifugal is the force that pulls the body away from the center of a circular part. And what are the applications of motion in a cycle? Okay, like angular velocity, angular acceleration, centripetal force, centrifugal force, all of them are motion in a circle. So what are their applications? How are they applied in real life? JAMB wants you to know all these. The first application we have here is on vehicles on curved roads. So vehicle on curved roads, when the road is curved like this, you apply some form of force, okay? The change of rates of angular displacement, okay? There's a change of rates, there's a change of angle in a curved roads. So you also apply it in satellites orbiting Earth. The way satellites move around the Earth, that one is centripetal force, okay? Moving around the circular path, okay? Then for centrifugal force, it's applied in centrifuge. If you've taken my lectures on separation technique in chemistry, centrifugation is a separation technique, and it's used to separate particles from a solution. Separate particles from a solution. So that force, through using a centrifuge, you use that centrifugal force to pull those particles from the center, okay, of the circular part of the solution. It pulls those particles from the center, and the particles will now be found on the sides of the test tube or whatever you're using to centrifuge this substance. So that's it. These are the applications of this motion in a straight line, and I explained each. This vehicle on a curved road, you know, is changing angle. This one is for the angular velocity and the angular acceleration. So this one you have here is for centripetal force. Satellites orbiting the Earth, rolling around the Earth, keeping a body in the circular part. That force that keeps the body in that circular part. Then for centrifuge, okay, I just give the example. That is for the centrifugal force pulling a body from the center of a circular part. Simple harmonic motion, SHM. Simple harmonic motion, SHM. What is a simple harmonic motion? Simple harmonic motion is a to and fro movement whereby acceleration is directly proportional to displacement. So acceleration is directly proportional to displacement. So acceleration is directly proportional to the distance covered in view of a frame of reference. And This same acceleration that is directly proportional to displacement is directed towards a mean point. I explained a mean point, what a mean point is when we were treating vector and displacement. So if you have a to and fro movement like this, let's say this is a to and fro movement, to and fro, okay, or to and fro. This is a to and fro movement, for example. This is the to and fro movement. Where is the mean point? The mean point is where it hits and returns. So this is the movement, okay? It hits and it returns. This is one mean point. The other mean point is here, where it hits and returns. It hits and returns, okay? So that's the mean point. So it says it's directed towards mean point. This acceleration is not only directly proportional to the displacement of this motion, but is directed towards the mean position. So that the acceleration is also directed towards the what? The mean position. For example, pendulum, small oscillations. You know pendulum bulb. These are the objects that observe the simple harmonic motion. Okay, like I said, mean point, hit, return, go back, 2 mean points like this. Pendulum bulb. Okay. The next example we have here is vibrating string. When you strike a string in a string instrument like guitar or solenoid, for example, you strike this string, you notice that it vibrates, it oscillates. Okay, it oscillates like this. There is a mean point that string doesn't pass. So remember that the acceleration of that string when you strike it is directly proportional or is equal to the displacement. The distance moved in a specific direction of the string is directly proportional to it. Okay, so if you strike it with a higher acceleration, it's going to be directly proportional to the what? The distance moved in a specific direction. Then if we now use displacement in turn, if you displace the string, you give it a higher displacement, okay, it's also equal to the acceleration. It's also going to determine the change of rate of velocity of that string. That's simple harmonic motion for you. And also this acceleration of this string or whatever instrument or object is directed towards the mean position. That's where you see the wave go towards. Okay, the wave flows to the mean position, returns to another mean position. That's it. Another example we have here is spring mass system, and so on and so forth. Okay, so what are the key terms under this simple harmonic motion SHM? The first one we have here is T, this capital letter T. This is usually the time for one oscillation. The time for one oscillation, that's T. And we also have frequency, which is F, which is the number of oscillation per second. That's the definition of frequency. Some textbook will tell you the number of particle vibration per second. Another textbook will tell you the number of cycle per second. So any of them is correct, but it's important you know the 3 definitions of frequency. They are easy. One is vibration per second, one is oscillation per second, one is what? Cycle per second. All of them, they are all interconnected, okay? Because they can ask you a question whereby you need to apply the knowledge of vibration or the knowledge of oscillation or the knowledge of completing a cycle. So that's it. And remember, since frequency is the oscillation per second, the formula will be F is equal to 1 over time. Remember, time signifies the second. Second is time. So 1 over time. Okay, that's the formula of frequency. F is equal to 1 over time. Then the next we have here is amplitude, which is A, which is the maximum displacement from mean position. The maximum displacement from the point of rest. So let's say here is the 0 mark. This place in my video box is the 0 mark. And here is the point of rest. Okay. And this place is the mean position. Okay. So the maximum displacement, the maximum distance covered from this point, which is the mean position, to the other side, the other mean position again. This place, so this place is the what? Is the amplitude. Okay. But in wave, you are going to calculate the 2 amplitudes, both the one you get up and the one you get below. That's why they say amplitude is the distance between 2 crests and trough. This maximum displacement you have on the upper part of the waveform is known as crest. While the one you have below, you know that if it goes down, you will not do like U under, okay, to form another circle under. The one you have below is known as trough. Okay. So that distance between that crest, one, then the one under trough, is known as what? Amplitude, and that is 1 circle. Okay, 1 circle of particle vibration. So what is the equation of simple harmonic motion? The equation is, when you are calculating displacement in simple harmonic motion, you use this formula. S is equal to A sine bracket open angular velocity times time bracket close. This one, if you are looking for displacement, that's when you apply this formula. Okay, they gave you a simple harmonic motion question. You are hearing the motion of an object in a to and fro movement or in a circle, something like that, and they tell you what is the displacement. This formula, that's what you are going to use. Always remember that sine is the angle, okay? Sine, whatever you are giving, okay? Whatever you get here, you are going to do the sine of it. So remember that JAMB doesn't give you calculator. So you have to be familiar with your SOHCAHTOA, okay? Your SOHCAHTOA, adjacent, opposite, hypotenuse, and all of that. You have to be familiar with that. Very familiar. It's very easy to know. It's very easy. All those ones are basic mathematics. So that, for example, you have sine 50 here, or you have sine 90 here. You should know what should be there. Even when you don't have calculator, because the kind of calculator you find in your JAMB UTME, or you can't see sine or cos inside. All you have in that calculator is just basic mathematical signs like plus, times, minus, equals. The highest you can see there is square root, and it has nothing to do here. So that's that for displacement. Then the next we have here is velocity. If you are told to look for velocity, you are going to use this formula. V is equal to angular velocity root bracket open, a square minus x square. Remember that s here stands for what? Displacement. Okay, just like here. S here stands for what? Displacement. S square. So a square minus s square. A square minus s square. You substitute, you look for your square root, you substitute, and you get your answer. Then if you are told to look for acceleration, it's still easy. This is the easiest formula. You just do a is equal to what? This is acceleration, is equal to what? Minus angular velocity squared times what? S. As easy as that. Remember what s is. S is what? Displacement. Very easy. Very easy. Very what? Very easy. Energy changes. Energy changes. What is energy changes? When we say energy changes, it means that the difference in energy. Is the energy higher on this level? Is the energy lower on this level? What is the change in energy? The difference between two energy or between energies. That's the energy changes. Okay. So let's look at what we have here. At mean position, take note of the laws. At mean position, kinetic energy is maximum and potential energy is minimum. At mean position. When you say at mean position, it's just like at the maximum position. Okay. At the maximum height covered. At the maximum position. As the high position. That's the mean position. When you say mean, the highest. At the highest position. So for example, I will define what kinetic energy is and what potential energy is for you. The simplest term. Kinetic energy is an energy found in a moving object or an energy that moves an object. Okay, in a moving object, anything moving is kinetic energy or kinetic energy. Whatever method that pleases you in pronouncing it. Okay, so that's kinetic energy. Energy in a moving body. Okay, or that makes a body move. That's kinetic energy. And potential energy is an energy found in an object at rest. Okay. So that energy that makes an object to be at rest or an energy that is stored in an object at rest. You can store the energy in an object at rest by virtue of its position. So the energy of the object is based on the virtue of the object's position. It's the position of the object that determines the energy. That is potential energy. It's a stored energy in an object. Okay. And it's also the energy that keeps an object at rest. Okay. An energy of inertia. Okay. I already explained what inertia is. So that is what potential energy. And this energy is not an energy that shows itself. That's why it's called potential. Okay, it has a future. Okay, it can be used in the future. For example, potential energy is the energy found in petrol, fuel. Okay, so it's a stored energy. It's an energy that has a future. You can use it. You can transform it to kinetic energy, to heat energy. Energy stored in an object. So when we look at this, this postulation or these principles according to energy changes, it said at mean position. When you say at mean position, it means at the highest level. At the highest level. At the highest level of movement, is kinetic energy not maximum? Yes, it's maximum. But at that highest level, potential energy is minimum because it's the energy stored in a substance by virtue of its position. At extreme position, potential energy is maximum, while kinetic energy is zero. Simple, Shikina. I'm explaining it to you again. At extreme position. Now we are talking about position now. I told you at mean position. When you say at mean position, it means mean height. When there is movement. We talked about mean position when we were discussing a simple harmonic position. When there is movement, the highest distance covered in the movement or the highest extension in the movement, the highest extent to which an object goes in a movement. That's the mean position. Okay, so there's movement. So kinetic energy is maximum, potential energy is minimum. But at extreme position, extreme means the first position. Before anything happened, the potential energy is high because you know that potential energy is an energy experienced based on the virtue of an object of its position. The virtue of an object's position, the virtue of the position, that's what is an energy possessed by an object by the virtue of its position. So that's what potential energy. That's why potential energy is maximum here. Okay, and kinetic energy is zero since it's an energy in a moving object. Okay, so total energy is equal to constant. So the total energy of the system is equal to constant. Total energy is constant, provided that what no external force acts on it according to the law of conservation of what momentum. So forced vibration. Jamb said you understand what forced vibration is. Forced vibration is external periodic force that drives a system. Forced vibration. You force something to vibrate. All those people that used to wind gen to start gen, you wind the lister when it starts. Forced vibration. You force it to start. Another one is when you are starting your gen. All those your small better pass by neighbor gen and all those gen. You draw it to create that kinetic energy. Forced vibration. Force to start. Force to start from the external. You do it from external, outside. Okay, force from outside. So that's force vibration for you. Resonance is the maximum amplitude. Got it? The maximum amplitude. I already explained what amplitude is. The distance between a crest and a trunk. So when you say the maximum point of displacement, that's a resonance. The maximum displacement from the mean point, that is what resonance. It occurs when driving frequency is equal to natural frequency. So when driving frequency equals natural frequency, there's resonance. You get your maximum amplitude, your maximum cycle, maximum displacement. That's it. So resonance occur when driving frequency is equal to natural frequency. Take note of that. What is the application of resonance? Jamb said we should add this to our arsenal. Radio tuning. You use resonance in radio tuning. Driving force equal to what? Natural force. In musical instruments, you use resonance in what? Music instruments. In bridges, such as the Tacoma narrow collapse and so on and so forth. Those are the application of resonance. Conservation of linear momentum. We have treated this before, but let's quickly take a glance of it. Okay. This law states that total momentum of a system is constant if no external force acts on it. So if a car is moving and no external force acts on it, no external force, no force from the outside acts on it, it's going to continue moving forever and ever. Linear momentum, momentum on a straight line, okay? Momentum on a straight line will continue if no external force acts on the body. Linear momentum is going to continue till eternity. That's the law. So the application of the conservation of linear momentum, that's momentum cannot be destroyed, okay? It continues to remain constant provided that no external force acts on the body. That's it. The simple explanation of this principle of the conservation of linear momentum. And its application is under the collision of gas molecule. For example, gas molecule will continue to collide if no external force acts on it. Rocket propulsion. Rocket propulsion. A rocket will continue to move, okay? It will continue to move in space in a projectile motion if no external force acts on it, because the momentum of the system, the total momentum remains constant if no external force acts on it. And this is the formula, a very easy and sweet formula. I said anything u is initial velocity, that's beginning velocity, first velocity. Anything v is final velocity. And m that you are seeing here is the mass. This is the mass. Mass 1, initial velocity 1. Mass 2, initial velocity 2, equal to mass 1, final velocity 1. Mass 2, final velocity 2. When you substitute into this place and you substitute into this place, you solve here, basic mathematics, you solve here, what you get here and what you get here, you divide both sides and you get your linear momentum. Let's move over to period and frequency. What is the relationship between period and frequency? It's time. So the relationship between period and frequency is F is equal to 1 over T. That is the relationship, okay? This relationship you are seeing here is the formula of frequency. So that is the formula of frequency. So for example, if period equal to 0.5, this is a question. If period is 0.5 seconds, what is the frequency? The frequency is equal to 2 hertz. How did we get 2 hertz? Remember, the SI unit of frequency is hertz, okay? Hertz, okay? How did we get 2 hertz? When you substitute 0.5 into this formula here, 1 divided by 0.5 will give you what? 2. As simple as that, chicken. Now that we have understood simple harmonic motion and beyond, let's now test the knowledge we've acquired so far by taking some Jamb must repeat questions. Jamb must repeat question. Question 16. A car covers 100 meters in 20 seconds. What is its average speed? A. 2 meters per second. B. 5 meters per second. C. 10 meters per second. D. 20 meters per second. Drop the answer in the comment section. Question 17. A body starts from rest and accelerates uniformly at 2 meters per second for 10 seconds. What distance does it cover? A. 20 meters. B. 50 meters. C. 100 meters. D. 20 meters. Drop the answer in the comment section. Question 18. A ball is thrown vertically upward with a velocity of 20 meters per second. Take gravity equal to 10 meters per second square. What is the maximum height reached? A. 10 meters. B. 20 meters. C. 30 meters. D. 40 meters. Drop the answer in the comment section. Question 19. A projectile is launched with a speed of 40 meters per second at angle 30 degrees to the horizontal. Take acceleration due to gravity 10 meters per second square. What is its time of flight? A. 2 seconds. B. C. 6 seconds. D. 8 seconds. Drop the answer in the comment section. Question 20. A force of 50 Newton acts on a body for 0.2 seconds. What change in the momentum does it produce? A. 5 Newton seconds. B. 10 Newton seconds. C. 15 Newton seconds. D. 20 Newton seconds. Remember what the change of momentum is equal to. Use it to solve this question. Drop the answer in the comment section. Question 21. A projectile is launched with a speed of 25 meters per second at angle 60 degrees. What maximum height does it reach? Take acceleration due to gravity equal to 10 meters per second. A. 15.6 meters. B. 18.8 meters. C. 23.4 meters. D. 26.6 meters. Drop your answer in the comment section. Question 22. A ball is projected with velocity 20 meters per second at angle 30 degrees to the horizontal. Take acceleration due to gravity equal to 10 meters per second square. What is its time of flight? A. 1 second. B. 2 seconds. C. 3 seconds. D. 4 seconds. Drop your answer in the comment section. Question 23. A projectile is launched at 45 degrees with speed 14 meters per second. What is its range? Take acceleration due to gravity equal to 10 meters per second square. A. 14 meter. B. 19.6 meter. C. 20 meter. D. 24.5 meter. Drop your answer in the comment section. Question 24. A car of mass 1000 kg moves at 20 meters per second around a curve of radius 50 meters. What is the centripetal force? A. 400 Newton. B. 8000 Newton. C. 10,000 newtons. D. 20,000 newtons. Drop the answer in the comment section. Question 25. A wheel rotates at 120 revolutions per minute. What is its angular velocity in radius per second? A. 2 pi radius per second. B. 4 pi radius per second. C. 6 pi radius per second. D. 12 pi radius per second. Drop the answer in the comment section. Question 26. Which of the following best defines simple harmonic motion? A. Motion with constant velocity. B. Motion with acceleration proportional to displacement and directed towards mean position. C. Motion with constant acceleration. D. Motion with varying speed only. Drop answer in the comment section. Question 27. A simple pendulum has a period of 2 seconds. What is its frequency? A. 0.25 Hz. B. 0.5 Hz. C. 1 Hz. D. 2 Hz. Drop the answer in the comment section. Question 28. At the mean position of a vibrating spring mass system, A. Potential energy is maximum. Kinetic energy is 0. B. Kinetic energy is maximum. Potential energy is 0. C. Both kinetic and potential energies are 0. D. Both kinetic and potential energies are maximum. Drop the answers in the comment section. Question 29. Resonance occurs when A. Driving frequency equals the natural frequency of the system. B. Driving force is 0. C. The amplitude is always constant. D. The system is at rest. Drop the answer in the comment section. Question 30. A force of 200 Newton acts on a body for 0.1 seconds. What change in momentum is produced? A. 2 Newton seconds. B. 10 Newton seconds. C. 20 Newton seconds. D. 40 Newton seconds. Drop the answer in the comment section.